Okay, so I wanted to start with a bit of background on genetics of BMR. You don't have this handout. It was completed about an hour ago. So I sent it to the main office, and someone's bringing it up just a little bit ago. I wanted to make sure you had the most timely information. Didn't want to give stuff that was, a year old or 10 years old. And I've got a bit of detail, but I don't want to go into a lot of detail. We're going to talk about BMR, or brown midrib, sorghum Sudan grass, sorghum, other warm season annual grasses as we move through the day. But I wanted to give a bit of background so you know what we're talking about, so you know a little bit about how the breeding worked on this as well. I don't, Dennis. It'll be here in about an hour. Yeah. So this means you got to pay real close attention, then I'll give you a handout so you've got the information. Okay, a number of seed companies. Yeah, Chris?
Can you turn these lights down in the front?
Sure, Chris. See if you can figure it out. I didn't. Yeah, is that got it? Okay.
Is that better? You want these down a little bit more?
You all okay, or down, or are they okay? Okay, great. My recording's going to sound a bit funny, but you all will know. Okay, so a number of seed companies now have available BMR type annual forage grasses. So I'm not trying to promote one or the other, but Avanta's one that's developing a number of new sorghum Sudan grass, pro millet varieties. Avanta, their seed sales is through Alta Seed. Greg, is that the best way to say it? And so in their literature, and I don't mean to promote their particular varieties, but this is an example of the types of things that you see in the literature with the advantages of BMR. So for example, milk production pounds per day, this BMR 6 sorghum, 75.2, corn 74.36, BMR 18, 70.84, conventional sorghum 68.2. That was in Journal of Dairy Science about 10 years ago. So that's the kind of information. That's all very valid data, but obviously each company is going to pick something that looks a little better for them. And as we go through the day, we'll be showing you a lot of information. Dennis has some current information. Chris has some current variety test information. So that's true, but that's not true for every BMR sorghum Sudan or sorghum. And in my talk, I'm kind of throwing all the warm season annuals in together. Most of the BMR are in the sorghum species, sorghum Sudan, some in Sudan grass. There's just a few pearl millets that have come out recently with BMR. So Cromanton is another company developing a number of new sorghums. And again, BMR is a top priority. This is Lacrosse Seed website. Greg, you all are, I guess, getting the license for several from the breeding companies and then putting that out to distributors. Galen Ward is another main breeder. And am I right, Galen Ward, Cromanton, Avanta, are those the three main breeding companies, or am I missing?
Coffee seeds.
Coffee Seed as well, okay. And Chris has some data on several of their varieties. Now, I was looking to find a good, detailed, simple explanation on the genetics of BMR, and I came across an excellent article, and in fact, you'll have a copy of this article as well, put together by these folks there at Texas A&M. So I'm going to give you a couple of excerpts because it explains the process well and has a good bit of data going along with it. So just bear with me as I read through a couple of things here. The BMR mutation has been identified in or introduced into corn, so that was all the way back to 1926. Sorghum, Porter 1978, Sudan grass, pearl millets, churning 1988. So a fairly recent thing in the sorghums and the millets, and much more recent as far as a good number of commercial cultivars coming out. The name brown midrib, so that's where BMR comes from, refers to the reddish-brown pigmentation of the midrib of the leaves of these phenotypes. So we'll look in the field this afternoon. You can pull some out, and we'll look at those characteristics. In sorghums, cut a stalk in half. You can see reddish-brown pigmentation in the pith of the stem, and it's associated with the vascular tissue. Now, the The brown midrib in the leaf, and I know Dennis and Chris have a couple of pictures of that, that can fade as the plant matures. So it's not always apparent. You don't always see that brown midrib. However, the pigmentation of the stalk remains in mature plants. So for those of you county agents or company people, if you've ever done like myself and you said, oh, this is a brown midrib type, I'll show you what to look for, and you've looked at the leaves, then often people have said, well, I can't tell anything there that's different. So Dennis yesterday cut some stems open so we could see. Okay, the BMR trait is a recessive trait, and I'll give a couple of examples in humans with recessive traits and how that works. When present in the homozygous state, the BMR mutation is associated with a reduced lignin content, higher forage digestibility. A number of references there. So, big thing to remember is BMR stands for reduced lignin, higher forage digestibility. Now, I won't go into the chemistry of that reduced lignin, and some of that's still being understood. And in fact, there's some recent work I'll mention at the very end of some new work to have reduced lignin in a little more engineered type ways. So here's a couple of examples of recessive traits. The widow's peak, where your hairline comes down more at a point. That's a human gene. That gene has two alleles, one for widow's peak, one for a straight hairline. The widow's peak is dominant, so that should be what most of us have if we take our caps off or pull our hair back and take a look. The straight allele is recessive. So if you've got two widow peak alleles, you've got the widow's peak. If you've got just one, since it's dominant, you still have the widow's peak. But if you have the two recessive genes, so remember humans, we've got two chromosomes, or two copies of each chromosome. So if you've got two recessive genes, one on each of those chromosomes, we've got a straight hairline. Rolling of the tongue is another dominant trait. So most of us should be able to roll our tongue like that. If you have the two recessive genes, you can't. Now, I didn't know this till I was looking it up last night. If you fold your hands and cross your thumbs, that's actually genetically controlled. So everybody do that. The dominant is that your left thumb goes over your right thumb. That's just what feels comfortable. If what feels comfortable to you is that your right thumb going over your left, then that's recessive. So you would have two recessive genes. So meaning that from each parent, you got that gene for putting the right over the left. So the long and the short of why I say that is with BMR, it's recessive. So the breeders have to make sure that they've got just the genes for the BMR to be able to have that expressed. Okay, reading just a little bit more, the BMR trait in most commercially available sorghum cultivars originated from 3 chemically induced mutants. So people have often, in fact, I've had several people say, well, I don't want to get a BMR type sorghum sedan grass or sorghum because it's genetically modified. Okay, chemical mutagenesis or radiation is simple, taking the plant material itself as chemical mutagenesis. You're putting the seed in a chemical that's causing some genetic changes, and then you're planting, you do that with a lot of seed, and then you plant that seed out, and then you identify whether you have a BMR mutation. So it's something that's accepted as just a traditional breeding practice. You're not introducing any new gene into that material. Those mutants, the BMR mutants, as well as cultivars developed, as we said before, characterized with less lignin, higher digestibility, and just a little bit of data there at the bottom. Okay, now this is very important, and in fact, I didn't realize this until I'm just researching the last few days. So Porter, back in '78, he developed with this chemical mutagenesis 19 BMR sorghum genotypes, but chemically treating seed from 2 grain sorghum lines. Okay, they were numbered BMR 1 to 19, so he used a real sophisticated system. I made 19, let me number them 1 to 19. Of the original 19 mutants, 13 were selected for further evaluation in paired field plots to their normal sisters. So, you know, he had all of these mutations, and he was comparing them to that same material, those same 2 grain sorghum lines that had not been, didn't have the mutation. Based on 2 years of field evaluation, he suggested that the BMR6, BMR12, BMR18 from his original 19 should be selected for further evaluation. And there are more of the BMR6 and BMR in his process than there are the BMR18. So until I was looking this up, I thought that there was some genetic control, that you had some 6 genes and 12 genes or 18 genes, but it's really a very simple process going back to Porter in 1978. So this is actually in Porter's literature, going back to his comparison between the BMR6 and the normal, the BMR12 and the normal, and the BMR18 and the normal. And the point here is less lignin in the stem, in the leaves as well. But so the A here means comparing the stem between this BMR6 and the normal, it was significantly different. And you'll notice here for the lignin and also for the in vitro dry matter digestibility, in every case, all of these BMRs were significantly different with I think there's just one exception right here with the leaves. Now I'm putting this up because if someone's really curious, Cherney in 78, I'm sorry, I think it's 88, he developed 2 inbred pearl millet lines, and the main reason I'm showing this is the chemical that you're soaking it in, ethyl-methyl sulfonate, diethyl sulfate, and that goes into a little bit more of the breeding there. There's the citation. So it's a really pretty straightforward process. We've got Seth DeBolt at University of Kentucky that is making some new BMR-type mutants and using those to study just how cellulose and lignin deposition happens in plants. I was looking for information, and I pulled up Raleigh Zurich was a former PhD student of mine at University of Manitoba. In fact, one of the smartest guys I know. He was the kind of student, Deidre, you remind me of Raleigh a little bit, that I learned a whole lot from. When Raleigh first came from Yugoslavia, that was before things split up and things were kind of getting dicey there. So he called to ask if he could come and work with me. He was not using SAS. He didn't know how to use SAS. He just had an Excel that he was doing 4-way anovazone based on the formulas that he had written in there. He's now the director of the Plant Breeding Academy at UC Davis. That you didn't really need to know that. That was just an aside of a grad student I'm proud of. But I was looking for some information on how to explain this process. And I think what I'll do, rather than taking the time to pull up this animation, let you look at that on your own, because they've got a nice little animation with backcross breeding. The main point that I want to make with this is that, so you had these 2 grain sorghum lines that were, we had these different BMR 1 through 19 mutants, and now we're mainly working with the 6, 12, and 18. Okay, to get that into an improved sorghum Sudan grass hybrid, or sorghum or Sudan grass, or like with the pearl millet that were developed later, it's quite the process. It's not just a simple thing. So you get it in the plant material that you want, but then to get it into the improved cultivar, there's a number of cycles of backcross breeding. I'll let you look at this on your own, but the long and the short is you've got to go through a number of cycles. This is just what they call the backcross 1 generation, where you're taking your F1 that has the BMR, crossing that with the elite inbred. In this case, you've got 75 elite genes. You keep doing this, typically about 6 or 7 crosses, having to grow the material, get the pollen onto the other plant, plant the seed. So a number of generations to get to where you have an improved cultivar. Then you've got to test that improved cultivar. I'll give you all an example in just a minute. So part of why it's taken so long for us to see BMRs come out is it takes a long time to get that improved material out there. There's no simple, quick way. There's no simple, GMO technology to insert the gene. In our current climate, I'm glad there's not a simple GMO technology because we have such a regulation over that. The first BMRs that came out, again, remember going back to those 2 grain sorghum lines, if you think of the first sorghum Sudan grass BMR cultivar, you know, it probably still had a fair bit of background of that grain sorghum type, so people often talked about, well, those first BMRs had a real yield drag. They weren't that good at cultivars. It was because they had the trait, but they hadn't had all the years yet to get that material put through. So just let me give an example of this. I pulled this up. Dr. Bill Rooney is a sorghum breeder at Texas A&M. He developed a BMR, the first BMR brown midrib sorghum cultivar. It's a dual grain and forage cultivar in Central America. So this is what he did. He took the local grain cultivar, Tortillerio, and crossed it with his BMR that he had right here. The F1 was back crossed, again back to that local material. Selections were made. So that was a local adapted cultivar. He was trying to get the BMR into it. So it was tested there in El Salvador for agronomic appearance and stability of the BMR trait. You want to make sure the BMR trait's there. The resulting BO 3292 was selected for the BMR trait in agronomic adaptation in College Station, Texas, and in Puerto Rico. Okay, if you're trying to move through the generations and do testing, there's a lot of that sorghum seed is grown in Puerto Rico because they can grow it in the wintertime. So the cultivar came out, this CI 0941 BMR, selected for testing, after testing in 6 countries. Because even after this initial evaluation, you made sure there was the BMR trait, you made sure there was agronomic adaptation, but that was only in Texas and Puerto Rico. That was more just for the seed production. You still wanted to make sure that it fit in these other countries, and you wanted to make sure that it was adapted, in their case, to pretty low management conditions, because his goal was a BMR for the local sustenance farmers there. So I didn't have the timeline for a number of years, but you add up the years to get to this point, it's probably was a 10-year process. Okay, the last thing I'll mention, and this is just one example of an article, but I'm mainly wanting to make the comment of Seth DeBolt in horticulture at the University of Kentucky, and others in that field are using similar processes to make new BMRs. Now, Seth is a basic researcher. He really wants to study, really how that happens. How is the cellulose laid down, the lignin laid down in the plant material, so that, really from a basic science standpoint. But what I think will come out of his work and other work similar to that will be probably new BMRs that we have a lot better understanding of actually what's happened there, not just that they're less lignin, but the lignin, the way that it's laid down in the plant material, still gives the strength to the plant, but gives improved digestibility. Okay, any questions? Okay, now the rest of the talks today will be a little bit more practical than my genetics talk, but Bill, go ahead.
The same material, same physiology, I guess, and genetics would apply to corn, BMR corn.
That's right. So the BMR corn would go originally back to 1926, but there's would have been a number of other ones before that, but the same process to get a BMR into corn. They've had a longer time period to do that, so more improvements. And that fact of the first BMRs, we talked about it last night, Greg, there were less lignin, but lignin is what holds plants up. So you get a storm come through and it knocks it all on the ground, so it's no good to have higher digestibility if it's on the ground full of dirt, you can't get it up. And we really haven't understood real well exactly what's happening in the plant until just starting to recently to know how do we have less lignin but still hold the plant up. Yes?
Is there somewhere you can find nutritional analysis of the different cultivars?
You'll see some of that today in the talks. And so after Chris and Dennis talk, we can do some follow-ups. Now, part of what we're talking about, we'll talk about at lunchtime, is just how to come up with some charts or something like that so you can actually compare across cultivars. There's not a real good universal collection, Chris, that would compare cultivars.
There's some low lignin alfalfas now, right?
Mm-hmm.
Is that a BMR gene, or is that
So the low lignin alfalfa is a different process, and the BMRs are just in grasses the way that works. That is a genetically modified. So they did modify the lignin pathway in alfalfa. So it goes through all those regulations. But actually the low lignin alfalfa will be available, I think it's next spring. We'll have some for probably some demonstration. Probably next fall before commercially available. Is that right, Greg?
My understanding was 2016.
Yeah. And one of the advantages in alfalfa that they're finding is not just you have higher quality alfalfa. If you cut alfalfa at the right stage, it's pretty good quality, but it can be allowed to go to a later maturity and still maintain a good quality. So a year like this in Kentucky and surrounding states where it's kept raining, you let it go 2 or 3 weeks past and you still got a decent quality hay. And again, that's something to look for closely if you're looking at varieties. If you're looking at company literature, particularly looking at literature from testing, was it scored for lodging? Was it compared to varieties that I know that don't lodge? And I believe most of the material, some of the very first ones that came out, Greg, did have some lodging issues, but I think most that will be commercially available shouldn't be an issue. Yes.
Are you going to talk about the rachitic dwarf gene today at all?
I won't talk about it. We'll be referring to it. Dennis and Chris, you'll probably have some information on that. Not a lot of detail in the field. We've got some rachitic dwarfs. We can talk about that in a little bit more detail there. There's several novel genes in the sorghum Sudan, like the rachitic dwarf that has shorter internodes, so it's a much leafier plant. There's the photoperiod sensitive, the types that they're not going to produce a seed head for 170 days, so they mainly stay vegetative. If we don't get to that during the day, we'll for sure see those in the field and talk in a little bit more detail. Okay, I'm on time. Yesterday, the moderator, when I was speaking, didn't keep himself on time, so make sure I don't do that today. Chris, let you adjust me over. Or next